Hello, welcome to Notes 8.04. Today we're going to be looking at what's called the law of sines. Now, the law of sines is different than SOHCAHTOA. Remember, SOHCAHTOA is reserved for right triangles because the hypotenuse is always opposite your right angle. Here, we're going to have the law of sines today. Now, this is used when you're given sides or angles of oblique triangles. When there's no right angles. So an oblique triangle is just a triangle. It could be scalene typically, but it's not going to have any right angles at A, B, or C here. And what it says is the formula goes side A, so in the numerators here, A, little B, little c are the sides. Okay. And in the denominator is sine of angle A. So remember, capital letters are our angles. So it says side A over sine of angle A equals side B over sine of angle B. And then similarly, side C over side of angle C. Now, typically, we're only going to be taking two fractions at once. So here, let me just write a note, only two ratios at once. So we're looking at the relationship between two different sides and the angles opposite those sides. So don't get hung up on the lettering here, but just remember, if you have an angle A, B, C, F, G, H, whatever the letter might be, that capital letter A is an angle. The side that's opposite it is its lowercase letter, is how we kind of look at that. Let's jump into exercise 1. Use law of sines to find the length of AB. So AB already has the x on it. And how this relationship goes, remember, it's side over sine of its opposite angle. So side here, measure is x. So from A to B is what we're trying to find. That's going to be x over sine of its angle opposite is going to be sine of 86. And remember, that's some decimal equivalent. We just don't know yet. Next is going to be the side 38 goes into our numerator over sine of its opposite angle, 51. And from here, we're going to cross multiply. So 38 gets multiplied by sine 86, x times sine 51. So I always start with my x value. So remember, x times sine 51 equals 38 sine 86. And to get x to stand alone, we need to divide by sine 51. So looking into the calculator, we can turn that on. Now here, when this sine 51 cancels out, x is just standing alone. This entire side is a whole fraction. I'm going to type that whole thing in at once. So if you do have your graphing calculators, remember we have the option to do alpha y equals enter and pull up that numerator denominator. So in the numerator, we're going to put 38 sine 86 in. The denominator is sine 51. And hit enter, and you have your full answer there. So this is where we always write out our answer to 4 decimal places. So x equals 48.7777. Okay. So again, I want to see that long decimal written out first. Then please, please, please go back to the question and reread where to round to. A lot of you are forgetting some of our final answers. So here to the tenths place, which is what a 7 is, we're going to bump that up. So the final answer is going to be 48.8. So remember, in the picture, that means that this side is approximately 48.8 units long, and that's opposite that 86-degree angle. Looking at exercise 2, here we use law of sines to find the length of AB. So AB is what they're asking for, and again, we're going to round to the hundredths when we get there. So we're going to put the x here on AB. Our law of sines says a side x over sine of its opposite angle, 53, equals a side over its opposite angle. So the other side they give us is that AC is 7. We're going to have 7 over sine of 40. So there's our setup. Side over the sine of the angle, and the side over the sine of the opposite angle. Our cross products give us x times sin 44 equals 7 times sin 53. Here again, those are being multiplied, so we got to divide over by that sin 44. And x equals. Now, some of you don't have the fancy graphic calculator. Remember, you can always do the numerator first, hit enter, and then divide by the denominator. So I'm going to do it this time. So 7 times sin 53, the numerator. You can close your parentheses, hit enter, then take that decimal and divide automatically by sine 44. Okay. So if you need to do it in the 2 steps, that's A-okay. So 8.0477 is our answer to 4 decimals. Then we would approximate to the nearest hundredth here. It does ask us to round to the hundredth. So 0.4 would be hundredths place, but that 7 is going to bump us up. So it's going to be 5. Those are the first 2 examples on the front page. Again, I'm hoping that you're writing these down as you're watching the video today if you don't have these printed already. Again, the best way to learn these is to handwrite out what we have. So if you need to periodically pause the video to draw the next diagram, you might not necessarily need to write out the question piece, but at least have the picture drawn so you can set up your functions here. So looking at number 3, use the law of sines to find the length of BC. So here we have a triangle. We know AC is 16. We have 2 angles, and they're asking us to find the length of BC. So starting into our law of sines, x goes over the sine of 93 as 16 goes over this angle down here. So that's where we encounter our first little trouble spot. So that angle we don't know yet, but we have the other 2 angles. So we can take 180 minus 58 minus 93 and find angle B here. So remember, if you're circling your angles and kind of drawing an arrow to the opposite angle, if you're circling your side and drawing an arrow across, you'll always be using the right angles. So 180 minus 58 minus 93 gives it that this angle is 29 degrees. So here, going back into our ratio, we have x over sine 93 equals our side 16 over sine of 29. And cross products. Now here's a little shortcut now that we've done a couple of these. What we're going to do is here, this denominator gets multiplied up to this numerator. We're always going to keep that sine 29 in the denominator because it's going to end up being divided over. So our fraction goes x equals 16 sine 93 over sine of 29. Now the reason that happens is you can kind of multiply multiply both sides by that denominator to kind of clear it out. So when I multiply this side by sine 93, that cancels. Then this fraction over here gets multiplied by sine 93. So here, I'm going to go back to my alpha y equals answer option. 16 sine 93. And then sine 29 goes in the denominator. Enter. And we get 32.9574. And again, check to what we need to round to the hundredths, please. So our final answer is going to be 32.96. Because that's 7 bars 5 up. Exercise 4, we're actually going to skip. It's trying to find an angle, which we don't for this course this year. Number 5 is a double triangle problem. So looking at this, let's just look at the picture and see what we're given. For the figure below, find BC. So BC is the measure they want us to find. So I'm going to put a Y there for now. I'm going to use X for something else, and I'll show you in a second. To the nearest whole number. So in that triangle, that right triangle, ABC, I have an angle and I have a side. I would need to know one of these other two sides in order to use SOHCAHTOA. Because again, remember right triangles, we can use our SOHCAHTOA rule. Okay. But they give us a measure over here in this non-right triangle. So if I trace that one out from A to C, again, this log, A to C, G, back up to A. That triangle, we know an angle here and 15. Now these two triangles, if I go back over and outline our right triangle here, they share a side. That side is what we're going to put our on. So the steps to these double triangle problems is to first redraw the two triangles, kind of so that they're separate from each other. Second step is to find all angles. And then you're going to set up trig functions to find x and then find y. You're going to need two different setups to find each. Now, what I mean by a trig setup is like sine of 75 equals x over 15. Now, those numbers have nothing to do with this problem, but that's a trig setup where you would then cross multiply. I'm going to take that out for a second, but that's what I mean when I say trig setup. So redrawing our two triangles. The first triangle we had, and I'm going to leave them situated just as they were. So here the right triangle is kind of on the left side of the diagram. Okay. And what we know in there is that we have side Y and we have an angle of 65 so far, and we have that right angle. And across its hypotenuse next to the 65, there is side X. Then our second triangle is the oblique triangle that has no right angle. It has a measure of 15 down here, an angle of 20 degrees. So far I've redrawn the two triangles. Now find all angle measures. So remember that this 65 and that other angle at C make supplementary angles. So 180 minus our 65 is going to give us 115 degrees for this obtuse angle here. Well, now I know two angles of my big triangle. So if I take 180 minus the 115 minus 20, I know some of you can do that in your head, gives you 45 degrees for the third angle in that the triangle with no right angles. So that's the triangle we have the most information about. two different sides and we have all the angle measures. So that's where we're going to start, and we're going to use the law of sines. So let me put this picture up a little. So here I'm going to start a trig function. We're going to start with x over sine of its opposite angle 20. Use our law of sines equals the side 15 over its opposite angle 45. And the little trick we did the last question is that we're almost going to multiply both sides by sine 20, which is this denominator. So then in the calculator, we can put in that fraction there. So remember, if you didn't have the alpha y equals fraction option in your calculator, you just type in your numerator, sine 15 times sine 20, and then divide by sine 45. If you try to do it all at once, you have to be careful. 15 sine 20, some of you I know will try this. Close the parentheses there. Divided by, let's do that once, sine of 45. So if you are going to try to do the whole equation out only in one line, you could. Just make sure you use those parentheses to close it. Otherwise, it does some division first before, from time to time. So here we get 7.2553. Now it's important to keep 4 decimals here because this is only part of our answer. We need that x value here in our right triangle. So we can't round this yet. If we round here, this value of y is going to be affected. So we're going to keep our 4 decimal places. I know it's kind of a pain, but you're actually going to see it's not that bad if you're typing in one thing to the next. So now, looking at the second triangle, we need to set up a new trig function to find y, which is the measure BC that they're asking us for. So to find y here, we now have a right triangle, so we're going to think SOHCAHTOA. We have its adjacent side of 65-degree angle. We have the adjacent, and x is the hypotenuse. So adjacent hypotenuse is our cosine function. Here we're going to have cos 65 equals the adjacent side, y, over our 7.2553. Now in this case, here we just cross multiply. So y will equal these multiplied together. So in your calculator, you have that 7.2553 as the last answer. You're just going to take that and multiply by cos 65. So into your calculator, you're just going to hit times, because your answer is going to kind of copy and paste down, cos 65. And our answer here for y is going to be 3. Now again, if we had rounded here, that's going to affect these next decimals. But the final answer for BC is rounded to the nearest whole number. So BC for our final answer will just equal 3. So I know it seems long, but again, we're using our law of sines here first. We set up a side over its opposite angle, a side over its opposite angle. So please make sure you're finding all the angles. Now, for your homework today, I'm going to actually change a little bit of what we have. Now, again, most of you don't have this printed yet, but here, exit ticket 804, I do want you to try those 4 questions as the first part of your homework. So I don't know why it keeps pulling down. And then also, I just want you to do the front of 804B. So I want you to do 1, 2, 3, 4 here, and I'm sorry, 1, 2, 3 here. I'm not going to have you do this question 4, 5, or 6 quite yet. We'll come back to it at some point, but not right now. So your homework, again, if you went to school and picked up the packet, is going to be this exit ticket page. and homework 804, just the front, 1, 2, and 3. So giving you a few hints here on the exit ticket page. Come on, every time. When do you use the law of signs? So if you want to pause the video, go back up to the beginning. I would like an answer for that. And if you're answering this just on loose leaf paper, what I'd love you guys to be doing is kind of labeling what you have. So when I'm looking at this to grade it, I'll exit to correctly. Exit 8.04. So I want you to label the top of the page and then kind of number it. Number 1, and then you could write your answer. You don't need to rewrite the question. Number 2, I would suggest drawing out the picture and then setting up your trig function from there. Same with number 3, I'd love to see the 2 triangles kind of redrawn, which we're going to go over in a second. So if you're trying to handwrite out your answers, please clearly indicate a diagram and your answer, your work shown, so that I can grade these as efficiently as possible to let you know how you're doing. So for number 2, I'm going to make a note. I'd like you to round here to the 10th place. That was a typo to fix before we printed these for you all. But we're finding AB. So AB is where your X is going to be. So if you were to set up your law of sines here, so again, this is not a right triangle. So we're thinking a side over sine of an angle equals another side over sine of the. So the new stuff we just learned. So X is a side over sine 63 will equal 9 over sine of this angle here. So first step in this question, you do have to find what 180 minus your 101 minus your 63 is. So you need to find that angle first here, so that you'll have, again, X over sine 63 equals 9 over sine of that missing angle. I believe it ends up. So there's your setup for number 2 if you needed help with the new stuff. I would like to help you redraw your diagrams for number 3 and make sure you know what you're looking for here, because I know this is all new for us. 2 fire trucks are parked 150 feet apart. So we have one truck over here. The truck would be there. From a burning building. And there is a man stuck on the top of the building. The angle of elevation from fire truck 1 is 35 degrees. The angle of elevation for fire truck 2 is 48 degrees. Determine how high up the person is to the top of the building. And again, we're going to round to the nearest foot for our final answer. So again, I'm going to put a Y here because that's going to be the second value we can find, because we have 2 triangles formed. We have our right triangle from the man down perpendicular to the ground up the building. And then we also have the second triangle where we have the 150 and 35 degrees. Now remember, we know this other angle at fire truck 2, that's 48. This angle right next door, that obtuse angle, is 180 minus 48. Just check my math this morning, is going to be 135. So here we're going to redraw those 2 triangles. So if I sketch the first triangle and sketch that second one and relabel them. In the right triangle, I have my 48 degrees. I have my opposite side Y that we need to find. In my oblique triangle there, the small triangle, we have 35. We have 148. I'm sorry. Let's do that. 148. 132 132. I'm writing that correct. 132. So if I subtract those from 180, so 180 minus the 132 minus our 35-degree angle, that's way over here, will give us the third angle in that triangle up top is going to be 13 degrees. So again, we have 35, 132, and 13 there. And again, its bottom side is 150. So again, within this triangle to the purple triangle, they share that, I'm going to say hypotenuse measure. So it's the hypotenuse of the purple. Whatever x is here is going to translate to the hypotenuse there. So I want you to use that setup and go back to the last question from the notes to try to help yourself. I'm going to give you a hint for number 4. A helicopter is flying at an elevation of 575 feet above a horizontal highway. So that means the helicopter here is 575 feet up and it's perpendicular to the ground. The two motorists are driving cars on the highway. The angle of depression from the helicopter to the first car is 28 degrees. The angle of elevation to the second car is 35 degrees. So remember our alternate interior angles. We'll put that 28 degrees inside this right triangle here. And then same thing on the opposite side, that 35 degrees is going to bounce down into this angle here. Find how far apart the cars are to the nearest foot. So what we're trying to find is the entire distance from one car to the next. Now that's kind of split by these two right triangles. So my suggestion for this question is to find side X, which is from the car to this point directly below the helicopter, and then to find Y from this point here, no idea, to the second car. So we're going to find two measures X and Y and then add them together for our final answer. So the final answer is going to be X add Y this case. So we have the first right triangle to the left. And when I keep saying right triangle, you need to be thinking SOHCAHTOA. So this is not going to be the new stuff, that law of sine. So here we have 28 degrees, we have 575, and you're looking for side X. The second right triangle, you have a 35-degree angle, side Y, and again, 575 is that height there. So you'll need two trig functions to find X and one to find Y, and then you'll add those up for your final answer. So there's a few hints 1 through 4. Then again, homework 804B, I just want you to do 1, 2, and 3. Number 1 should be self-explanatory. Make sure you put the X on AB. You might have to subtract to find the angle. Exercise 2, I'll help read with you. A post is supported by 2 wires. So here we have this telephone tower is supported by 2 wires down to the ground, one on each side going in opposite directions, creating an 80-degree angle between the wires. So again, this is a wire here connected to the ground and another wire, and the angle between them is 80 degrees. So that's the whole angle formed between those 2 wires. The ends of the wires are 12 meters apart on the ground. So from one end of the wire here to the opposite end is 12 meters. With one wire forming a 40-degree angle with the ground. So one wire, and this looks like the smaller angle, is going to be 40 degrees with the ground. Now here we have the triangle, wire, wire, ground. Okay. Now that's not a right triangle. 80 and 40 adds to 120. 180 minus 120 gives us 60 degrees for the other angle. So wire 2 here makes a 60-degree angle with the ground. What they're asking for is to find the length of the wires. So if you need that picture kind of redrawn out, we have 12 down here, we have an 80 up top, we have a 60 to the left, and a 40 to the right. So there is your oblique triangle. They're asking for the length of each wire. So we need to find the length of wire X and the length of wire Y. What you're going to do is you're going to do two different law of sines setups. Kind of split my little page here. I'm going to find X one way, and then you're also going to have another answer set up to find Y. So X is opposite your 40-degree angle. Now some of you would go back and say, oh, and Y is across from 60, but then we'll have two variables in the same setup. We don't want that. Here we're going to use 12 over sine of 80. Okay, so that's one setup to find X. You're going to do a similar setup with Y and 60-degree angle, and then again that 12 to sine of 80 as well. So that's for number 2. It's not all that bad. And number 3, in the rhombus, ABCD. Rhombus. Okay, so this is kind of jumping back to our unit 5. The rhombus, remember, has 4 equal sides, diagonals that are perpendicular, hint, 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 gives you right triangles. So if AB is 17 and A to C is 16, now AC is the whole measure is 16. Remember that AC is a diagonal, and diagonals are bisected. So that gives us that here to the middle is 8, and here to C is going to be 8. So determine the length of BD. So they want the length of the other diagonal. Now this says hint, not with trigonometry. So we're not going to use sine, cosine, or tangent. We need to find that whole diagonal, which is bisected. So what I'll say is, you want to be finding from this middle point to be first in this right triangle when you have two sides given. That's not jumping out at anybody. My hint there is going to be the Pythagorean theorem. Okay. The second part is to find the measure of angle ABC. Now here's when you're going to use SOHCAHTOA, because that's when you find angles of right triangles. And if I help redraw that right triangle for you, what we know so far is 8 and 17 of one of the right triangles. So again, that's that green one kind of redrawn. But this angle at ABC, another rule of the rhombus is that diagonals bisect this angle. So that angle at B, if I kind of sketch it off to the side here, is broken into two pieces. One piece is the angle here. So if we put a Y in there, because I'm guessing you're going to use X for up here, you're going to find angle Y, and then to find ABC, you're going to take 2 times angle Y, because it's going to double, because both parts of that angle are equal. So those are a couple hints for your homework. Good luck with everything. Please email me if you'd like to set up a Google Meet session and we can chat. Thank you.